Okay, for this homework assignment, I'm going to have you watch these problems and then write down the secret message to prove to me that you watched this whole video. So here we go. This first problem here, I need you to know how to graph an equation in slope-intercept form, which is y all by itself and everything over on the right side, preferably with the x term first and the plane number second. When you get it in slope-intercept form, that first number all by itself tells you where to put that first coordinate on the y-axis. On 5 on the y-axis, that's my very first point. From there, you look at the number in front of x, which is your slope, and slope is made up of rise over run. If it's a whole number, put it over 1. That top number tells you the rise, the bottom number tells you the run. If the rise is negative, that means from that starting point, you will be going down 2 boxes and then to the right 1 box. So down 2, right 1, because that slope is negative 2. So from that point 5, down 2, over 1, down 2, over 1, down 2, over 1. Be able to stair step that the opposite way, going left 2, up 1, realizing those are equivalent slopes. Down 2, right 1 is negative 2. Left 1, negative 1, up 2, 2 over negative 1 is also negative 2. All these slopes will be negative 2. Right 2, down 4, negative 2. Left 2, up 4, also slope of negative 2. So that is the equation y equals negative 2x plus 5 graphed. I'd like you to also take a point on the line and off the line and be able to check it. I'm going to take the point 1 for x, 3 for y, over 1 for x, up 3 for y. I'm going to take that coordinate for x and y and plug it in. I'm also going to take a point off the line and check that one too. And I'm going to use 5, 1. So when I plug a point on the line, it will work in that equation, give me a true statement. So x is 1, 3 is y. Where there's a y, I'm going to plug in 3. That negative 2 is still part of the equation. Where that x is, I'm going to plug in 1. And I still have that plus 5. So that gives me 3 equals negative 2 plus 5. That is a true statement. 3 equals 3. That is a true statement. When I plug in 5, 1, that point will not work. The point 5, 1 for x and y, I'll plug in 1 for y and 5 for x. That will not work. So 1 for y, I still have that negative 2. Gives me 1 equals negative 10 plus 5. That is a false statement. Any point not on the line will never satisfy that equation when you plug it in. So 1 equals negative 5 is a false statement. That is a no. Okay, problem number 2 has you graph a system of equations, 2 equations on one line. If they meet in one place, that means you have one solution. So the first equation, I'm starting at 1 on the y-axis, and then I look at that number in front of x. If there's no number there, I put a 1 there. I need to take any whole number and put it over 1 to get rise and run, which means from 1, every time I go up 1 box, I go right 1 box. Up 1, right 1. Up 1, right 1. Be able to stair step to the left direction. Down 1, left 1. Remember, all those are equivalent. Up 1 over 1. 1 over 1 is 1. Down 1, left 1. Negative 1 over negative 1 is also 1. Over 3, up 3, that's equivalent. 3 over 3 is 1. All those slopes on that line will be 1. Then I need to graph the second equation. The second equation has a y-intercept of negative 3. So I put that first point on negative 3 on the y-axis. So negative 3 on the y-axis. From there, I look at that number in front of x, which is 2. Made into a fraction is 2 over 1, which means from the starting point, negative 3, every time I go up 2 boxes, I go right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. And then up 2, right 1, 2 more times. Be able to stair step that in the opposite direction. Down 2, left 1, which is still equivalent. Negative 2 over negative 1 is 2. And now I need to see where those lines intersect. If a system intersects in one spot, like I said, that's one solution. Know that just by looking at the graph. So I'm going to label my lines. That is y equals 2x minus 3. And the other one is y equals 1x plus 1. I need to find that point where they intersect and plug that point in. The first word is blue. Blue. So that point is 4, 5. Which means if I take that point 4 for x, 5 for y and plug it in, it will work for both equations. X is 4, y is 5. So when I plug that in, I'm going to plug in 5 for y in that first equation and 4 for x in that second one. I didn't put the 1 there because anything times 1 is the same number. So when I plug in 5 for y and 4 for x, I get 5 equals 4 plus 1, 5 equals 5. That is a true statement. When I plug in that point into the second equation, 5 for y, that original 2 is still there, 4 for x. That gives me 5 equals 8 minus 3. That is also a true statement. 5 equals 8 minus 3, 5 equals 5. Whenever you have an intersecting point, that point for x and y will satisfy both equations, give you true statements for both. Next problem, I need you to write the equation of this in slope-intercept form. Be careful, I might write the wrong slope, so I'll have you fix that. But that y-intercept 7, that is the plane number that goes in that slope-intercept form, y equals mx plus b. So y-intercept is 7. So all I need is two numbers. I need the number in front of x and the plane y-intercept number. So that 7 goes right here. And now for my slope, I'm going to go down 3, right 1. So that is negative 3 for my rise. And for some reason I write negative 2 right there. So fix that. That is negative 3. Going down 3, right 1. So if I put those two numbers together, that is negative 3 over 1. So not negative 2 over 1. So I need you to fix that. So the slope is negative 3 over 1. So change that to negative 3 right there. So that number, that negative 3 over 1, which is equal to negative 3, that number goes right in front of x. So that is negative 3. So my equation, when I put that negative 3 in front of x, is y equals negative 3x plus 7. So again, make sure you change that. That's not y equals negative 2x. That slope is really going down 3 over 1. So that is negative 3 right there. So that equation is y equals negative 3x plus 7. All right, next problem for slope. For my equivalent slopes, I need you to know the slope of this line and be able to describe that in a couple of different ratios or fractions or slope triangles. So for this slope, if I go and connect 2 points and follow that little pattern, every time I go up 2, I go right 1, up 2, right 1. That is slope of 2 over 1, a slope of 2. So slope of that line again is up 2 over 1. 2 is my rise, 1 is my run. So that is 2 over 1. Up 2 is positive 2, right 1 is positive 1. So that slope 2 over 1, I need to be able to find equivalent slopes of that. So I need to find all different ways I could show equivalent slopes of 2 over 1, which is 2. And again, I'm going to erase that and write a 2 right there. So I need to find other slopes. So if I go up 6, 1, 2, 3, 4, 5, 6, and go right 3, if I put those two numbers together, that should give me equivalent slope of 2. So up 6, I'm sorry, this looks like 8. 1, 2, 3, 4, 5, 6. Yep. Going up 8 over 4. 8 over 4 is equivalent to 2. Going up 8, right 4. Positive 8, right 4. So I fix that and write a 2 right there. So 8 over 4 is equivalent. That's the same slope. 8 over 4 is 2. That slope is on the same line, going to have a slope of 2. So 8 over 4. That's 2. Another way of showing a slope of 2 using a ratio or a little slope triangle. And I'm going to erase that so I can show it more clearly. If I went left 2, negative 2, and down 4, negative 4, that's also equivalent. Negative 2 for my run, going left, negative 4 for my rise, going down. Putting those two together is negative 4 over negative 2. That is also 2. Equivalent slope. All my slopes on this line are 2, whether I go up and over, positive, positive, or to the left and down, negative 2, negative 4. All those slopes are equivalent. Another way I could do it is if I go left 4, negative 4, and down 8, negative 8. That is also equivalent to 2. So left 4, negative 4, down 8, negative 8. Negative 8 over negative 4 is also equivalent to 2. So negative 8 over negative 4 is 2. All those are equivalent slopes to 2. And I think I do one more here. So again, another equivalent, if I go right 6 and up 12, all those are equivalent. Going right 6 is a run of 6, positive. Going up 12, a rise of 12, that's positive. So 12 over 6 is also equivalent to 2. All those slopes are 2. The second word is dog. Dog, D-O-G. All right, next problem, special systems. So again, these have the same slope, different y-intercepts. They're going to give me parallel lines. To get that by graphing, find 4 on the y-axis. Look at that number in front of x. That tells you to go up 1 over 1, up 1 over 1. So up 1 over 1, up 1 over 1. Be able to stair step the opposite way. Down 1, left 1, down 1, left 1. All equivalent slopes of 1. Up 1 over 1, 1 over 1, 1. Left 1, down 1, negative 1 over negative 1 is 1. All those are equivalent slopes. So if I graph my other equation of negative 2 and look at that number in front of x, going up 1 over 1, up 1 over 1, that gives me 2 parallel lines. So up 1 over 1, up 1 over 1, same slope, slope of 1, different y-intercept, y-intercept of negative 2, gives me those parallel lines, which is a no solution. So again, no by looking at the lines, it's no solution. No by looking at the equations with same slope and different y-intercepts, no solution. You need to know both. So that is a no solution. Never intersect. Parallel lines. All right. Next problem has me graph 2 equations with the same line overlapping infinite solution lines. So again, just by looking at these, same slope, different y-intercepts. Same slope, same y-intercepts, same exact line, overlapping lines, infinite solutions, many solutions. So that first equation, I start at 5 on the y-axis. That slope is negative 2, made into a fraction is negative 2 over 1, which means from 5, every time I go down 2 boxes, I go right 1, down 2, right 1, down 2, right 1. Be able to stair step the opposite direction, left 1, up 2. Equivalent slope of negative 2, down 2, right 1, negative 2 over 1, negative 2. Left 1, up 2, negative 2 underneath, positive 2 is also a slope of negative 2. So when I graph my second equation, same y-intercept, and then that same pattern of going down 2, right 1, down 2, right 1, gives me the same line, intersecting lines. Infinite solutions. Anytime you have overlapping intersecting lines, infinite solutions. It touches everywhere, every single point. Infinite solutions. or many solutions. Okay, next video, almost done. Be strong. Next one. Alright, for these, I need you to know the special case, how they look, and how you could tell if you have one solution, no solutions, or many solutions. So remember, if they intersect in one place, one solution. If they intersect, never parallel lines, no solution. And if they overlap, infinite solutions. So that first one I'm looking at there, it overlaps in one place. It touches and intersects in one place. Any graph that looks like that for a system, more than one graph on one, or more than one line on one graph, that shows intersecting in one spot. That's a one solution. Those equations would have different slopes. So again, knowing by looking at the graph, if they intersect in one spot, that is one solution. The third word is store. 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 S-T-O-R-E. So again, graphs that intersect in one place, one solution. If you have graphs that are parallel, that never touch, that is a no solution. Never intersect. No solution. So again, never intersecting lines means no solution. Never touch. If they overlap, intersecting lines, that is many solutions or infinite solutions. So same line, overlapping line, infinite solutions. So again, know that look. If they intersect in one place, one solution. If they intersect in no places, parallel lines, no solution. If they intersect all the way, many solutions. So know those looks. One place, one solution. Parallel lines, no solution. Overlapping lines, infinite solutions. So know that just by looking at the graphs. The fourth word is weight. Weight. Alright, not only do you need to know from the way the graphs look how many solutions that you get, you need to know from just looking at equations without graphing how they look, how many solutions you're going to get. So I got all three here. So that first one, you got to know, always solve equations for y. You need to get that y all by itself for you to be able to compare slope and the y-intercept. So you need to be able to solve equations for y, do the algebra to get that y all by itself. So you be able to look and tell how many solutions that you have. So solving equations for y like we practiced. So that first one is solved for y, so I leave it alone. It has a slope of 5 and a y-intercept of 4. That second one, I need to do the math to it to solve it for y. So to get that y by itself, I eliminate this 2x. I subtract 2x on both sides. So that gives me y equals, do not subtract these because these are unlike terms. That gives me y equals negative 2x plus 6. So when I look at those, both those lines have different numbers in front of x. They have different slopes. Lines with different slopes mean one solution. They're going to meet in only one spot. So know by just looking at graphs if they meet in one spot, one solution. But if you have equations solve for y, different numbers in front of x means one solution. They're going to meet in only one place. So different slopes. Doesn't matter if the y-intercepts are same or not. As soon as you have different slopes, they intersect in one place, one solution. So one solution. And know that again by looking at the equations. Different slopes, one solution. If you graph them and they intersect in one place, one solution. Alright, the second problem. I need to solve both those for y. The first one I need to get rid of this 4. Second one I need to distribute and combine like terms. So I get y minus 4 equals 3x. So I'm going to add 4 to both sides to get that y by itself. Don't add 4 and 3x. Those are unlike terms. So add 4, add 4. That gives me y equals 3x plus 4. And that is that equation solved for y. (3x plus 4) solved for y. It's got a slope of 3 and a y-intercept of 4. Taking my second equation and solving that one for y, I need to distribute that 3 and then combine the two like terms. So I take that 3 and I times by both the x and the 1. So I distribute 3 times x, 3 times 1. And that gives me y equals 3x plus 3. Plus 1. And then I take that 3 and that 1 and I combine those like terms together. So that equation becomes y equals 3x plus 4. And again, you can see they are the same exact equation, same slopes of 3 in front of x and the same y-intercepts. Whenever you have the things that are same, that means intersecting lines. That means infinite solutions. So because they are both the same equations exactly, infinite solutions. Because they both have the same slope and y-intercept, infinite solutions. So know that just by looking at them. Same slopes, 3. Same y-intercepts, 4. Same line, infinite solutions. Different slopes. As soon as you have different, don't worry about the y-intercepts. Different slopes, one solution. Same slope, same y-intercept, same line, infinite solutions. So you need to know that just by looking at those equations without graphing. If I was to graph those would be overlapping lines. So that is a infinite solution. Same line. So same slope, same line, infinite solutions. And then the last one, solving those both for y, and then be able to compare the slope and the y-intercept. I need to take that top one and solve that for y by subtracting 4x on both sides. So that gives me 4x plus y equals 2. So I'll subtract 4x on both sides. And that gives me y equals negative 4x plus 2. And then I could see they both have the same slope but different y-intercepts. So that means you're going to have parallel lines that never touch, no solution. So again, now both are solved for y. I can see that the negative 4's, the slopes are the same, but my y-intercepts are different. That means they're going to be rising and running at the same rate, parallel, but touching different y-axis points. So that is a parallel set of lines, which is a no solution. Parallel lines never touch. So again, that would be parallel lines because they both have the same slope and the same y-intercept. I'm sorry, same slope but different y-intercepts. That's parallel lines, no solution. So again, know the look of graphs. If I have just the graphs, if it touches in one place, one solution. If they're parallel and never touch, no solution, parallel lines. If they're intersecting, many solutions, infinite solutions. Know by the graph looks how many solutions you're going to get. Also know by looking at your equations. Equations solve for y, different slopes, one solution. Equations solve for y, same slope, same y-intercept, infinite solutions. Solve for y, same slope, different y-intercepts, no solutions, parallel lines. And the fifth word is water, water. So good luck. I hope this helps with the quarter 4 concepts we've learned so far.